unintended and undesirable consequences of algorithmic decision making and propose a framework to think about it. And that framework is going to build actually quite nicely from some of the things that Michael mentioned. And perhaps we should have coordinated a little bit.
It's okay, I got to go first.
That's fair. It's not my definition of fairness, but it is fair. And I'm going to discuss this in the context of social media and personalization in general and filter bubbles. So there's some ongoing work with Alex Miller, my PhD student, who's seated at the back. I'm going to talk about some of our early work in that area as well. So I'll start off speaking a little more broadly about unintended consequences of algorithmic decision making, propose a way of thinking about it, then dive into the filter bubble problem, and see how that framework might apply there. So as we all realize, algorithms are driving lots of decisions. One report says that over a third of sales from Amazon actually originate from personalized recommendations. Google's algorithms drive a lot of decisions. The algorithm picks what goes in the first result. That gets 33% of our clicks. Algorithms decide who we date and marry. About 50% of matches on Match.com originate from algorithmic recommendation. And of course, on the newer systems like Tinder, everything is algorithmically determined, not 50%. If you look at Netflix, over 80% of video hours streamed on Netflix originate from recommendations, according to data scientists at Netflix. So this is their own study. At Facebook, again, news stories we click on, driven to a large extent by algorithms that figure out which of thousands of posts by people in our social network really deserves our attention. Now, in all these cases, we see that algorithms are driving a lot of choice, and clearly they provide a lot of value, but as Michael pointed out, there's a lot of examples of increasing concerns with algorithmic bias or unintended consequences, ranging from fake news to racial bias in recidivism algorithms, filter bubbles in social media, and popularity bias in algorithmic recommendations on e-commerce websites where products that are being consumed are recommended, and so the long tail doesn't actually get discovered and so on. And so there's many such examples of these biases, and as Kevin mentioned yesterday, there was this article by Kathy O'Neill, who's been a vocal critic of using algorithms for important decisions. And she says, among other things, most of which we don't agree with, because she said there's no academic work on algorithms. But setting that aside, she did say that when computers make decisions, a lot can go wrong. And so the question is, there is a systematic problem. What's a systematic way of thinking about it? And so how do we think about what is driving the unintended consequences? How can we predict the impact, and how do we fix it when something goes wrong? And is there one way in which we can think about this? And so often we tend to focus on algorithms, and I think Michael nicely talked about the pipeline of machine learning, which I think is pretty relevant. And beyond machine learning, if we think about the whole process of algorithmic decision making, modern algorithms, including machine learning algorithms, but also more traditional algorithms, increasingly rely on some data about the real world and make inferences about how the real world operates. Based on that, these algorithms make some decisions. Then finally, people, the users of these algorithms, make choices, and those choices may either be as simple as, do I continue to use the algorithm or not? Or in decision support systems, it is whether I take the algorithm's decision or overrule it and make my own decision, right? And so, and then of course the decision creates new data, and as Michael was saying, which creates a new model, and that process keeps iterating. And so when we think of something going wrong, it could be either with the algorithm, it could be either with the data, or it could be the way people actually react to the algorithmic recommendations. But more importantly, I feel it's actually at the interaction of these, and so that's going to be the main focus of this talk. It's what happens at the interaction of each of these inputs. So just to make this concrete, so let's say we look at e-commerce data, and algorithms are recommending what movies you should watch on Netflix or what news stories you should read on Google or what products you should buy on Amazon. So the data in these settings are actual decisions that have been made in the past of what we consume, or it could be reviews and ratings, so it's decisions on what we have reviewed or rated in the past. And there may be selection biases. We don't consume products at random, and we don't rate, even if we consumed a set of product, we don't also rate at random. We tend to rate what we love and hate, but not things in between, right? And so there are biases in terms of the data that we are observing. In terms of the models itself, one of the most commonly used algorithms for recommendation is a collaborative filter. People who bought this also bought this. So it's biased towards popular item. Something has to be bought or consumed for it to be recommended. And in terms of how people respond to these, people may respond to the recommendations in different ways. So you might say if the recommendation is for a familiar item, I might be more likely to buy it, or maybe it's the other way around. If it's familiar, I feel it's uninteresting and I don't buy it. So again, we also don't respond to the recommendations somewhat randomly, and so our choices also feed into the data. With sentencing algorithms, again, as Michael pointed out, there's biases in terms of actual crimes versus arrest records, right? In terms of how policing is done. So there could be biases in the data. There could be statistical biases in the algorithm itself. And then finally, the question is, what do judges do when they see a score from a system like Compass or anything else? Do they follow it uniformly, or are they more likely to act aggressively with a score for one kind of race but not another race, right? And so again, those biases in human decision making create a new set of data which might be different. And finally, it's social media. Again, we connect with people. We might have biases in terms of who we connect with, and in turn that creates biased data sets. There might be biases in the algorithms. So for example, Facebook's algorithm, when it sees 2,000 posts that it could show you, it uses tie strength as a key indicator of whether you would want to consume a post by somebody. Tie strength is seen based on the number of times you interact with that person on Facebook. So the algorithm itself is more likely to show posts by people with whom you interact more. You might yourself select who you add on the network. And then finally, of course, even when we see a set of news stories, we decide what we click on, and we might have confirmation biases. We might choose to click on stories that are consistent with our views. And so that can, again, drive filter bubbles. So all of these factors can contribute individually into an observed phenomenon, whether it's race bias or sentencing, whether it's filter bubbles with social media, or popularity biases with algorithmic product recommendations. Now, a lot of attention has been focused on the algorithm, as Michael was pointing out, and that's not the full pipeline. Increasingly, we are starting to realize the data matters a lot too. But I'm going to also point out that it's not just the data and algorithms, it's the human being as well. But also, it's not just the data and algorithm individually, it's how they come together. And so that's what I'm going to focus on. We can think about the impact of algorithms as, what does the data do? What do the data do? What does the algorithm do? And how do they interact together? So let's look at that in the context of the filter bubble, which is something that's been in the news a lot for the last year, so I don't have to define it, but just to set context, it's the idea that with personalization algorithms, we have the extreme ability to focus on our own interests, our own preferences, and filter out everything else. And this creates echo chambers. These echo chambers can be particularly problematic when it comes to news and certain kinds of media that forms our opinions and determines how we engage in social discourse in a democracy and so on. Now, there are actually two views on what personalization actually does in terms of these filter bubbles. Now, there's one camp that has been saying, hey, filter bubbles, are an outcome of personalization. This guy, Eli Pariser, he had a a book called The Filter Bubbles that talked about this. There was a book, Republic 2.0, that also talked about filter bubbles in media in general, but also talked about personalization as a driver of these filter bubbles. Cass Sunstein was the author of that. Now, there's another viewpoint, and this is a viewpoint that a lot of computer scientists have shared with me, and I've seen it in some of their work, which is that at the end of the day, the goal of the personalization algorithm is to share information among people who might not otherwise communicate. And really, the goal of the algorithm is to expose you to new content and create those connections with others, so it's unlikely that it drives this effect. So the question is, what happens in practice? There's been a lot of theory on this. I've seen only 2 empirical studies, and I'll quickly walk you through that, and then get to some recent simulations we've done to figure out, what happens with data, what happens with the algorithms, and so on. So one empirical study was something that I did about 10, 12 years back with a student, where we looked at personalization algorithms that recommend media we consume. And in particular, what we did was we had data from a music recommendation service, and that was for Apple's iTunes. And what that service would do, anytime you listen to a song, it would recommend other songs that are related or perhaps interesting to you. So for example, if I listen to Giant Steps by John Coltrane, it recommends other songs by Miles Davis, Frank Sinatra, and others. I want to clarify before you accuse me of having good taste in music, this is not a screen capture from my computer. This was from my student's computer. Now, in our data set, we had information on what people were consuming before they added recommenders and what they were now consuming after. So we could do a nice comparison of pre and post, and we had a control group which was not affected by recommendations. And I'll cut the long story short, but what we found was that first, these systems fundamentally alter the kinds of songs you consume. It's not a small change. They actually change the distribution of songs. For example, for us, in terms of genres of music you consume, they do fundamentally change it, and it's a pretty significant impact. Next, we looked at what happens to commonality. I mean, of course, in music, it's perhaps not as socially relevant, are we consuming the same music or not? But the idea is, these kind of personalization might be going on with news and other settings. So that's how we're thinking about it. So the question is, what happens to commonality in consumption? And what we found was, first of all, in aggregate, commonality or overlap in consumption increased. So the way we measured it is, think of a network where users are nodes and an edge connects to users if they have enough consumption in common. Okay? And so we looked at how many edges were created in this network after the recommendation, and there were more edges created, more connections between people. Now, overall, we found that these edges increased, and it happens for 2 reasons. One, people actually find more and more stuff that they like, and so they consume more. And the fact that you consume twice as much and Michael consumes twice as much implies that there'll obviously be more chances of overlap in consumption. But equalizing volume and just looking at the mix of content, we still find significant increase in that overlap as well. So it's both a volume effect and a mix of the content you consume. Now, this increase in consumption or overlap could happen, for example, if similar people consume more in common and dissimilar people actually become further apart, right? So in aggregate, it would get masked. So we looked at clusters of people. We asked, let's look at people who are very similar to each other before the recommendations and ask what happens. And what we found was that both close and far users, meaning similar and dissimilar users, actually overlap in consumption increased. And in this case, the algorithm was, increasing overlap and unlikely to be contributing to social media. Contributing to filter bubbles. Now, another study was done by Facebook. Of course, Facebook researchers studying if Facebook causes filter bubbles, there's a bit of a selection bias potentially, but this is a paper, not a report published somewhere. So this is a paper published in Science. So we'll talk about what they found. So they used data for about 10 million Facebook users for this period, July 2014 to January 2015. And they looked at people who have self-identified their political affiliations as either liberal, conservative, or moderate. And then they looked at what was social media doing in terms of their consumption of news content. So basically, they classified all of the content they were consuming into hard content and soft content, hard being news stories. And then they tried to see are people consuming cross-cutting content? Are liberals consuming content that is primarily conservative or the other way around? Okay. So first of all, they find that every news story that's there on Facebook, they classified it into, is this moderate, conservative, or liberal? And their algorithm actually assigns how liberal is the viewpoint in there and how right-leaning, left-leaning it is, and so on. And so across Facebook, what they show is that there's all kinds of content. Now, if we think about that framework I mentioned earlier, if we are not consuming cross-cutting content, it could be because of the data, it could be because of the algorithm, or it could be because of the choices we make. And so the question is, which one is it? So first thing we can look at is the data. The data are generated by choices we make. For example, who we add as our friends on Facebook. And so they first looked at who are your friends on Facebook. And so for liberals, it turns out most of their friends are liberal, very few conservative friends. For this group over here, conservatives, it turns out most of their friends are conservative, very few liberal, right? And so, part of the problem clearly is the underlying data itself, meaning that choices people have made in the past have created a world the algorithm operates in, which is already highly biased, and there's a filter bubble existing independent of the choices the algorithm makes. And the question is, what does the algorithm do? And then what do the people do in terms of their choices subsequently? And so what they find, well, if you were connected to random users on Facebook, you would consume a lot of cross-cutting content. But because you're not connected to random people, the amount of cross-cutting content you consume is lower. The algorithm makes that worse, but not by a lot. The algorithm is actually going with the data chosen, meaning your choices of friends. And then eventually, if you look at the choices people make, what articles do you click on? That makes things worse, much more so for conservatives and liberals. But bottom line, their message was, hey, it's not our algorithm, it's the data. Right? But you could argue that the algorithm itself makes certain choices. For example, it is saying this is the data it's going to use, and that it has to come from your friends, and it cannot come from anywhere else other than your friends. Right? So there is clearly a choice in the algorithm which has fixed the data set it will use for itself. And so let's look at that, and let's look at, how do we reconcile what's happened last year where everyone felt like, hey, we were in a filter bubble. Was that choices we made? Was that the choice of the algorithm, and so on? So I'll illustrate it through a very simple example, and I'm happy to later talk about implications more broadly. But the simple example is a simulation we ran. And for the simulation, I'm going to go back to, say, a news recommendation algorithm or a media recommendation algorithm. And essentially what we did in the simulation is we created a world where people have some preferences, and the content that might get recommended also has certain values along this preference space. So for example, so there's two attributes here. You can think of as many attributes as you want, and these two attributes here may be characteristics like, is this liberal, or is this more conservative, the viewpoint in the story, or is this sensational storytelling, or is it more understated and more research-based? So, and you could have as many attributes as you want. So every product or every news story has a position in this attribute space, and every individual has a position in this attribute space which denotes their ideal point. What is their perfect product for them? And essentially, users are more likely to consume items that are closer to them than that are farther away. And recommendations look at past choices people make, and then pretty much follow the algorithm to figure out what to recommend to the user. And once a recommendation is made, the user doesn't have to consume it. It just increases the probability that the user will consume the item. So here's a simple example where we essentially create this simulation where products are these X's here, and users are reds and blues, and reds and blues sort of say which type you are. And you could create multiple kinds of worlds or multiple kinds of people. So we create two worlds. One is a village where we'll call this the global village. One is a world which we'll call as the global village, where there are two groups, red and blue, but actually they differ not by a whole lot. Their positions are drawn from these circles that are actually quite overlapping. The other world is a polarized world where people have preferences with very little overlap, right? Very polarized world. So that's the data set that we create. People make decisions based on their preferences, which would come from one of these two worlds. And those are the two data inputs to the algorithm. Next, we pick two algorithms. One algorithm is the standard collaborative filter. Find people like you, ask what else have they bought, and recommend the most popular item that people like you bought. So this is essentially people like you also bought this, or people like you also consumed this, right? So that's the standard collaborative filter. The other is a collaborative filter that we use to try and increase more, create more exploration, more diversity in consumption. This is along the lines of what Michael was saying earlier. One way to correct for biases might be to take a deterministic system and make it more probabilistic. The deterministic system says, here are people like you, I'll recommend the most popular item. The probabilistic system says, here are people like you, I will recommend any of these items, and in probabilities proportional to their usage. So I'm more likely to recommend A than B than C and D, but everything has a chance of being recommended. So those are the two algorithms. And essentially, we run this simulation. We measure overlap again in terms of, create an edge between two users if they consume at least one news story in common. So there's at least some shared information base for these two users, right? And so now we're going to measure what happens. So these are the two dimensions. Data. Data can come from a polarized world or a world where it's a global village, and two algorithms, the standard collaborative filter and the stochastic one. And so here's what we find. So these edges connect people who have some overlap in consumption. Blue edges connect the blue guys, red edges connect the red guys, and the black edges connect people who have different ideological preferences. Okay? What we're measuring over here is the extent of overlap. So what percentage of edges are cross-cutting? Okay? So what percentage of your edges are with somebody from the other group? With the standard collaborative filter, with both the data sets, you can see it's nearly the same, 43% and 44% of the edges are with the other group. And what we see when we move to the other world is that changes. And so specifically what we find is that in a world where the original data are polarized, where people are highly polarized, one recommendation system, the standard collaborative filtering algorithm, actually is associated with far lower of this filter bubble kind of phenomenon than the stochastic recommendation algorithm. On the other hand, that reverses over here. When the data set is from like this global village kind of world, the stochastic algorithm actually increases the extent of overlap between these people. And so what it's saying is it's not, if your policy goal was, hey, I want to make sure my algorithm does not create these filter bubbles, well, the answer is it depends. In this world, I'm really worried about this algorithm, but in this world, actually, I quite like it. So it's not so much that the algorithm has a fixed effect. And similarly, if you look at what does the underlying data set do, if I'm using the standard collaborative filter, the underlying data set does nothing over here. So almost no change in the extent of polarization. So what's happening over here is that the data set doesn't matter as much. But over here, the data set matters a lot. And so what this is ultimately trying to say is, it's not like there's one data set that's a problem. It's not like there's one algorithm that's a problem. But when the two of them come together, it could be highly problematic. And so it's kind of this idea that sometimes data matters, sometimes algorithms matter, but it's also extremely important to ask, how do the two come together? And that's really the point here. And I see some hands up. It might be a good time for me to end as well. So I'll just end by saying I mentioned this in the context of filter bubbles, but you could ask the same question in any of these algorithmic decision-making contexts that Michael brought up or that I mentioned. And really the issue is the same. And what I illustrated that these interactions can be quite powerful was for a very simple algorithm. The collaborative filter is a super simple algorithm, no machine learning aspects to it. There's no learning as such going on in what I just described. Whereas in reality, the algorithms can be more complex. The data set that the algorithm is using can be far more complex than this simple data set I mentioned, and the systems can be less transparent in terms of how does it actually make the inferences it works. And so these interactions can be way more complex than what I described over here. So I'll end there.
Great.
Future work, I'll skip that.
Great. Thanks. All right. Great. Okay, now for something completely different. I'm going to talk about algorithmic power, but in a somewhat different way. And what I realized actually yesterday was that part of what's motivating me here is thinking back to the experience that a lot of us had looking 20 years ago at the growth of the internet and all these new services and companies and ideas, and feeling in hindsight that in many ways we got it right. It was true that there were these innovative small new companies and new techniques that were developing that needed to be protected, both against government power as well as private power. But in some ways, we were too naive in not anticipating the new kind of power that those new companies and platforms and techniques could create over time. And so I see something similar potentially emerging with a new kind of algorithmic power or algorithmic governance. But I want to start with a riddle. What's the best way to burn several $1 million? Traditional approach is you get stacks of $100 bills, cover them with gasoline. If you're on the show Mr. Robot, you put on this modern-day Guy Fawkes mask, stand in Battery Park, and light a match. But there's another way to do it that turns out to be considerably more effective. If you're DevOps 199, who's a GitHub user, you issue a function call that gives you control over cryptocurrency wallets, holding currency for people, and then issue another call that basically disables all of those wallets, instantly rendering $150 million worth of currency irretrievable. It's like it's in a bank vault, but the key is gone. As of right now, it's essentially permanently gone. Now, maybe not so permanently as I'll get to. But that's a lot of money. And that's certainly something that should give us pause in terms of the potential downsides or potential problems of algorithmic systems. Because when we talk about machine learning, we're talking mostly about techniques to guide decision making. But the technology that I'm talking about is a set of algorithmic techniques that can actually construct organizations and can actually enforce decisions and transactions, and that, of course, is blockchain. Now, people, yes, of course, now we get some hisses and rolling of eyes. I am not going to make any prediction about the price of Bitcoin. I'm not going to recommend the hot new initial coin offering that you should put your money in. Very clearly, this is a technology that's overhyped, that's immature, and yet one that looks a lot like internet technologies, again, in the early 90s, when you could see the potential. You could also see that they weren't entirely ready for prime time, but they were foundational. Internet technology, basically the idea that you could connect networks in this open and scalable way, was something that a lot of us in academia and a lot of people in the private sector and in the entrepreneurial community saw as a foundational advance, that even though at the time we were talking about it was something that was basically being used by small groups of geeks and entrepreneurs in small parts of the world, but something that, if it got traction, could be utterly transformative to every company, everywhere, and to daily life. Blockchain, in many ways, is a technology that has a similar kind of potential. We don't know if it will reach a similar level of influence, but it is similar in that it is a foundational open technology, not just for connecting systems for messaging, but for connecting value. And it's fundamentally a governance technology. It's an algorithmic technology for governing and managing activity. And so now is the time, even though it's way too early, even though there's very high uncertainty about how many of these things are real, which direction is the technology going to go, this is the time to start thinking about some of the potential problems and try to think about some of the potential responses. So I'm going to talk about this in a fairly preliminary way with more questions than answers, but to try to put some of these on the map and think about them within this context of algorithmic decision-making and algorithmic power. Blockchain, you've probably seen some of these statistics, starting with Bitcoin, but there are now several thousand of these cryptocurrencies. Aggregate market cap, if you just count up the amount of currency in circulation, somewhere around $200 billion, not a small number. Roughly 1,000 companies have done these initial coin offerings where they create their own native cryptocurrency token and sell it to investors, generating this year about $3 billion, substantially more than all the venture capital money that's gone into the space. And to me, also very interesting and very important, it's not just a bunch of crazy startups and a bunch of crazy developers. Enterprises and governments seeing the value here as well. This study from a couple months ago from Jupiter, 60% of large enterprises, by which they mean 20,000 or more employees that they surveyed around the world, seriously considering or implementing this technology. Now, the technology they're implementing is not exactly the same as the one some of the startups are implementing. I'm going to, for now, elide some of these distinctions. But they're all responding to the basic potential of a technology that creates a common view of information. This is a record-keeping technology. And record-keeping is foundational to all of capitalism, among other things. So a new way to engage in shared record-keeping across organizations and across trust boundaries is a tremendously powerful thing, and one that we should pay attention to. Very much in some ways like the internet of the 1990s. What is this technology? It's been called a technology of trustless trust. So the idea here is if you have a group of actors within an organization, across organizations, they don't necessarily trust each other. They don't necessarily trust anyone in the process. They don't necessarily trust any central authority, whether that's an intermediary like a financial exchange or a governmental authority, and yet they trust the outputs of the system. So that means with something like Bitcoin, you can trust that the Bitcoin balance you see associated with your private key is accurate, even though there is no central ledger you can look to. You just have the confidence based on the algorithms, based on the way the system works, that everyone is seeing the same information. Technically, that's called consensus. It's a process of getting the nodes in these networks to come to agreement about the state of the system. And there are various different ways of doing it. Broadly speaking, one approach, which is what the public networks like Bitcoin and Ethereum do, is now being called cryptoeconomics, combination of cryptography and economic incentives. This is the process you may have heard of with proof of work and mining and so forth on Bitcoin, where even though the actors that are verifying information are self-interested, the best strategy for them is to validate truthfully. Because if they do that, they maximize their chance of winning a reward, which is to actually get Bitcoin or Ethereum for being the one to validate a block of transactions. That's one approach. The other approach that most of the enterprises use involves a kind of thin layer of identity. So not anyone can operate on the network. There's some verification of who's on the network. But then once people are on the network, there's still decentralization. No one actor has control. There are various different structured voting algorithms. This goes back to some well-established research in Byzantine fault-tolerant algorithms, which people are coming up with new twists on. That doesn't have the same degree of pure decentralization as the public networks, but still allows decision-making with no one actor in control. And this gets even more powerful because these are computers that are processing things all the time. So a transaction on one of these blockchain networks is not necessarily just move a certain amount of Bitcoin from this key to that key. It's a program. It's a small application which in theory could do anything that we could code into an application. Now, there are all kinds of practical limits on doing that, scaling it and performance and so forth. But basically, this mechanism called smart contracts is a way of creating these self-executing applications on these decentralized networks, and then they self-enforce the transaction. There's no one that decides whether to enforce, and there's no dispute resolution on the network after the fact. Now, the way that these systems avoid any central control is immutability. So once something is recorded on the ledger, it cannot be rolled back. It cannot be changed. There's no super actor who can come in and say, no, that's a false transaction, give the money back. There's no government that can issue a court order saying reverse that transaction. It can issue an order maybe to individual actors to go do another transaction that sends the money the opposite direction if it's just a financial transfer. But there's no way to alter the ledger. It's basically tantamount to censorship or tampering for any actor to try to change what's on the ledger. And fundamentally, this works sort of like Odysseus in the Odyssey, where in order to protect against the siren's call to get him to dive into the water and drown, he had his men tie him to the mast. And then he had the men put wax in their ears so that when the siren call came, he himself physically was incapacitated. He couldn't respond. And when he kept calling out for his men, untie me, they couldn't hear him. So ex ante, ahead of time, he incapacitated himself because he knew at the moment that he would not have the power to respond in the way that he wanted to. Choosing to use one of these blockchain networks is somewhat similar. It's agreeing to an algorithmic structure ahead of time that precludes the notion of some central authority. And that it has interesting parallels to some of the challenges that we see with machine learning. It has the parallel in this division between the ex ante and ex post activity. Instead of the human at the end of the process making a decision, you get a loan, you don't get a loan, we build algorithms and models and apply data to them and use those to train to make the decisions. In some ways, it's similar to this blockchain approach of building in the logic of the smart contracts and then setting them free, as opposed to relying on something like a court to do dispute resolution after the fact. And there's similar kinds of problems that come up. So one is that, and this relates to some of the stuff that Michael talked about, and I think we'll hear about in the next group as well, some of the things that are relevant are outside of the system itself. So that involves things like, for example, biases in the data sets that Michael talked about in machine learning. In the blockchain case, the problem is this is a very powerful trust engine. It lets you trust that what was recorded on the ledger is actually what is on the ledger, and what you see is accurate, and what was put on the ledger tells you nothing by itself about whether that information is true. So let's say that there's a blockchain-based system for land title registration, application that's being tried out in lots of places in the world. That will ensure immutably that the land transfer recorded on the blockchain is what everyone else sees when they go and look at those land title records. That itself, however, does not tell you that it's a truthful registration. If you get some corrupt officer at the local land office to let you put on the blockchain a false land transfer, the blockchain will just happily record that immutably and make it impossible to change. So there is this problem of things that will happen outside of the system that are human-based activities. The question of intent also sometimes comes into play, as I'll talk about in a minute, which the technology itself can't solve just by recording immutably. The second issue is that there is this disconnect between the inputs and the outputs. So in the machine learning case, that's some of these notions of inscrutability, where we can see what the results are, but difficult to say, well, did the algorithm make this recommendation because this person was black? Turns out to be complicated for the reasons that Michael talked about technically. Similar issue in blockchain, except it goes the other way. There the question is prospectively, if you build one of these smart contracts, these programs that then make transactions and engage in activities on the network, do you know what they will do? Well, these are computer programs. And in some cases, it's fairly straightforward to formally verify, here is what this program will do. But in some other cases, it's a lot more challenging. And so there's a lot of work going into thinking about when can formal methods be used to understand what the actions will be of these smart contracts in the wild. So some of this is just applying that state-of-the-art knowledge on formal verification, but there are some categories where that might not be possible given the open space of different kinds of smart contracts that can be written. So what does this lead to? Things go wrong. First of all, potential catastrophic failures. Second of all, more subtle but in some ways more dangerous, creeping recentralization. So the whole value proposition here is get away from central control. Get away from the traditional corrupt or inefficient, what have you, systems of decision making. But in some cases, maybe we wind up with the worst of both worlds where we get new kinds of central control without accountability. Two quick examples. A year ago, something was created called the DAO, Decentralized Autonomous Organization, distributed crowdfunding, basically equity crowdfunding scheme. They got people to contribute Ether, which is the cryptocurrency of Ethereum, a thing like Bitcoin, to this automated smart contract-based system. In return, people got tokens, which let them vote on projects. The idea was development teams would say, here's my project, I want to get funded. You would vote, your tokens would go to the development team, and then if they hit certain milestones or generated revenue, you'd get some money back. $150 million of Ether contributed in about 2 weeks to this project. This was at a time when that was 15% of all the Ether in circulation. And then very quickly got hacked. There was a bug in the smart contract code. Someone figured out a way to siphon off about $60 million of that money to their own smart contract. Pure theft. But from the perspective of the application, the distributed application, and the smart contract code, it was a legitimate transaction. Right? This is about human intent. A human looks at that and says, that's a thief. But the machines looked at that and said, oh, that's someone calling a function that is available in the system, and there's no way to distinguish it from a normal transaction. And it's immutable. So there's no way for someone to say, well, let's pull the dead man's brake and send the money back. That function is what was prospectively taken out by using this approach. In the end, because this was an existential threat to the entire Ethereum network, the community, the foundation that oversees Ethereum, agreed to do what's called a hard fork. They literally broke the entire Ethereum network, not just the DAO, but the entire cryptocurrency, split it in two, and convinced enough of the miners, these verification nodes, to run that updated software, and had a new fork where essentially up to this moment everything was the same. From this moment on, magically, that theft transaction was reversed. Got all the money back. But there was the other fork too, where the theft still happened, which they thought would just sort of die out. There was a kind of dissident faction that said, you know what? Immutability is so essential. That's the whole point of this approach. We can't have some motley group of developers here saying, well, our friends are losing money, so we're going to reverse it. So they started mining the other chain. That's now called Ethereum Classic. Year and a half later, both still exist. All right, the main Ethereum, ETH, is worth a lot more, but Ethereum Classic is still there. So this is, in some ways, craziness, but shows the kind of problems that you get into in these situations. Now, forks are not inherently bad. A fork is a well-understood concept in open source software development, and the fact that networks can fork do provide potentially a valuable form of governance, but not in this kind of chaotic, misunderstood way. So the question then came up a year or so ago when this happened. Well, all right, we did this, we got over it. What's going to happen the next time something goes wrong? So the next time something went wrong at this scale was a couple weeks ago. This was the DevOps 199 example. There's something called a software wallet that holds your cryptocurrency keys for your currency. This is a wallet for Ethereum, which is being used for a lot of these ICOs. Company called Parity, run by the CTO of the Ethereum Foundation, so you would think would know what they're doing. They didn't. So bug in the code. Turned out that even though these are decentralized, all for sort of corner cutting to save money on the network. They basically had, when these wallets were initialized, they all used some preliminary template code. And then someone forgot to initialize all the wallets, allowed someone to basically call a function that prevented access to all of these wallets holding this $150 million. So the question is, okay, now what? Do we do another hard fork now? And then if we do, then what about the next time and the next time after that? Clearly, this is no way to run a railroad. So how do we get out of this? So what I'd like to suggest briefly, and I don't want to take too long, is just as in the privacy community over the last several years, the idea of privacy by design has gotten a lot of currency. We need to think about, in these blockchain networks, governance by design. Now, privacy by design has lots of problems. It's somewhat vague and so forth. But the basic notion that privacy is not something that just sort of happens at the end where sort of the system gets built and then the privacy people sort of think about it, that clearly doesn't work. This is something that needs to be fundamental to design processes at every stage. And similarly, in talking about these algorithmic fairness issues and other algorithmic problems with machine learning, this is not something that can just be done at the end. It needs to be thought about all throughout the process. In these blockchain networks, governance needs to be something that applies at every stage. The blockchain networks tend to think about governance just at the first level of the integrity of the ledger. This process of consensus is a governance process based on the algorithms of the network. It's actually fairly tough to do it well. Bitcoin has been very successful, but there are other systems that haven't been. But that's only one piece of it. Again, that only gets you the fact that what gets on the ledger stays on the ledger. There are three additional levels that are important, and I'll do each of them very quickly. One is, well, what if you need to override the rules? So that's things like the parity wallet case. Well, we all agree that generally speaking, money shouldn't be reversed, but this seems like a very good case where that should be possible. And I think about that a little bit like, for example, fair use in copyright, where we all agree that using a protected work is infringement, but there is a set of circumstances that, at least under US law, is recognized that is an exception to that. Now, very problematic in process and so forth, but at least conceptually, it's this idea that there is some escape hatches that need to be built into the system. Second situation is, well, maybe it's not just an escape hatch, a situation where the basic rules need to change. Because again, if everything is hard-coded ahead of time and everything is immutable, how do you evolve the system? How do you change the basic rules when circumstances change? And finally, then, what's the governance of the governors, the structures of people and organizations that manage these things? And the last thing I just put in here, ruminating on the conversation that we had yesterday and some of Yochai's presentation and so forth, we need to not be too afraid to think about the different actors that can be part of the conversation here. And that even though this blockchain technology coming from Bitcoin comes from a very libertarian perspective, if we are talking about building systems that work and scale and avoid some of the kinds of problems and dangers that we have seen very broadly with internet platforms, we need to talk about what can be done technically. We need to talk about what can be done collaboratively and collectively by communities and by non-governmental sources. But we also need to think about what role there is for state and regulatory actors here. So very quickly, the override situation. This is the idea that there's got to be escape hatches, which again need to be built in ex ante to figure out, well, okay, if there is this, for example, you're doing this distributed crowdfunding system, maybe there needs to be some scenario where what if a thief does steal the money? Now that can't just be, well, we're going to give this person who runs the foundation a veto, because then that's creating a single point of failure. So various kinds of political and bureaucratic mechanisms to cabin that central authority. But I think it's naive to think that for the wide swath of situations where these systems will be used, that can be avoided entirely. The second one is updating the rules fundamentally. This is where Bitcoin has run into trouble. The Bitcoin network is wildly overloaded. The costs, the transaction fees have skyrocketed because the network can't keep up. And there's a bitter dispute about what to do about it. Everyone agrees it needs to be updated in some way, but there's one developer community that thinks one thing, there's groups of miners that run these verification nodes think something else, and they've been at loggerheads. There have been various forks and proposed forks. There was a fork that was supposed to happen just about a week ago that got called off because it didn't have enough support. All kinds of chaotic fighting within the community, which perversely has given disproportionate power to certain actors. In some ways, people look at this and say, well, it's great, it's decentralized, right? No one can force anything through because it's decentralized. But you look at how the discussions are going, it's increasingly a small number of actors who are driving all of the decisions. And they're not necessarily the actors you would think. So Jihan Wu runs a company called Bitmain, largest mining operation, mining pool network in China. So controls the biggest chunk of Bitcoin mining, the computers that are actually processing the transactions. His company also makes the ASICs, the chips that are most widely used by these mining systems. He has a particular view about what Bitcoin should be based on he's running a company that's making, it seems like, at least several $100 million a year on these mining processes. And if you look at, though, the vision of Bitcoin, the idea that someone like that would have this disproportionate impact over decisions of the system is wildly inconsistent with the vision. So there is this possibility for these kind of subterranean authority figures to gain power without accountability. So what do? Well, again, we can learn from open source, commons governance mechanisms, ways to implement good governance on these kinds of actors, and potentially do some of it on the network itself. So there are a variety of blockchain systems being developed. The best known one is this thing called Tezos, which actually ex ante build into the blockchain code, the consensus mechanism, the possibility to change it, typically through some voting process. So based on how much of the currency you have, someone can propose a change, let's say increase the size of the blocks on the blockchain, for example, and then the network has some mechanism to allow decision-making on the chain through the algorithms, and then if something wins, to have it actually implemented in the system. That creates a lot of efficiency, but also creates its own set of dangers. So Tezos itself ran into some of these dangers because they didn't deal with the higher level governance problem. Tezos did one of these ICOs, at the time most successful one ever, $230 million they raised. And they set up a nonprofit foundation in Switzerland to control the protocol, to oversee the network. And they also had a private company of the developers, mainly a husband and wife. They ran the development and had the intellectual property, and set up a regime where the foundation controlled the network, they controlled the money, and they were going to buy the technology from the developers once it was ready. And then very quickly, the two sides got into a fight. The development team basically decided they couldn't work with the guy who was running the foundation. He had to be removed. Exactly what's going on and why is not entirely clear. But they basically got to the point of saying, we can't build a system for this foundation. The foundation, of course, which has the now $400 million at current value of cryptocurrency, doesn't have the technology to build the network. So this is a classic kind of human governance problem. And shows that even figuring out good technical ways to do the governance on the network doesn't necessarily overcome that problem. But again, governance is not a new question. It's a hard question. It's one that we've dealt with a lot on the internet. This is a little bit too flip, but ICANN is certainly something that has worked very hard over a very long period of time, addressing lots of controversies and been sort of the locus of a lot of debate on internet governance. We're going to see something similar in this blockchain world. And again, as I said before, I think the opportunity now is to try to get ahead of it before there is quite so much at stake. Last thing, just to show something that's happening right now. Gab is a social network messaging service that is preferred by the alt-right and neo-Nazis, used very widely for harassment, for people who get kicked off of places like Twitter. And they had the bright idea of saying, well, okay, blockchain, decentralized, no central power, sounds good to us. So they said, all right, we're going to do an ICO. And we're going to build a peer-to-peer, decentralized, uncensorable GAB network on top of Ethereum. And the response was interesting. Now, Ethereum, again, it's a global network of cyber libertarian, free speech absolutists. Immediately after this happened, some of the leading figures in the Ethereum community, their response was, we don't want you here. All right? Get off our lawn. This is not what we stand for. We do not stand for hate speech. We do not stand for harassment. That is not why we are building this technology. But it's kind of a difficult position to hold when you're building a technology that's designed to not allow these kinds of decisions to get made. So they are now starting to struggle with this question of, well, how do we draw lines? Is there a way for a decentralized community to have some baseline standards and not basically turn into what they were trying to run away from before, which is the problem of government power and the problem of private power in traditionally centralized environments? No answers yet. But again, I'd like to suggest this is something where we can learn from what's happening, obviously not a universally good situation, but the debates that we're having, some of the things we talked about yesterday about the power of platforms, some of the things that we've learned about governance in different kinds of decentralized communities. I think this is the opportunity to have these debates, and again, to also have thought about where can law and regulation play a helpful role in allowing these systems to be used for good and not for ill. So I'll stop there. Thanks very much.
Can people see me if I just sit, or should I
It's up to you.
stand? I'll sit so I can look at my computer.
Okay, knock it over.
Microphone on.
You know what, I'll just come back. We might as well come back over here for the Q&A. Yeah. So try to, yeah, on the top of it, there's a little button.
Ah, yes.
There you go.
Okay. Thanks, and thank you to Kevin for inviting me and giving me this pretty challenging job of commenting on these presentations without having seen any papers beforehand. Already giving my excuses. But let me start by with a few comments. I just make a few comments and then we'll open it up. So I want to start with a few comments on Kartik's presentation first. The first thing I have is actually a question that I hope maybe you'll answer after I'm done with the comments. Is I'm wondering what is the intuition that explains your result about the different effects of stochastic recommendations in the polarized and global village worlds. So I think one possible understanding, and I'm not sure how your worlds were designed, is that really this is just about less dispersion in preferences to begin with. So when you have a more polarized world, you have fewer moderates, which means fewer people who are kind of willing to try something different. And if you kind of combine that maybe with an idea of choice traveling by contagion, which might be there in your model since it's local, is that what's going on, or is it something else entirely? I think it would be really helpful to have an intuition about what's going on because of very interesting results. The second thing I wanted to just mention, and maybe this harkens back a bit to something that Yochai said yesterday, is that I think one of the things that sort of jumped out to me in the presentation and in a lot of the discussion of this sort is sort of the strong assumptions about exogeneity of choice preferences that seem to underlie these recommender systems. And I'm just wondering whether people have thought about that, I was intrigued by thinking that your model, your simulation model, might allow you to explore what happens if you relax that assumption a bit and see what you get. And then just more broadly, and this also relates a little bit back to Michael's presentation this morning, and this is like, I get to ask my question even though I didn't get to ask my question. But it relates to both presentations, is that it seems to me that one of the things that is not discussed much in discussions about machine learning and bias and algorithmic decision making and so on, is the question of what are the effects of feature choice. For example, in Kartik's model, and in the recommender systems in general, as he pointed out, the homophily effect, the fact that you have this large effect, relates to the fact of which features you chose to matter. Another kind of example of this that I've been thinking about lately is that in a machine learning context, you could get bias that results from feature choices to the extent that there are real cultural or some other sort of differences between people, and your features are just more sensitive to some people's behavior than others. So I just think that I'd throw that out as something I think deserves maybe more attention than it's getting, or at least more attention than I am aware of that it's getting. And then the second question of a similar sort, also relating to both Michael's and Kartik's presentations, is I think another question I've been thinking a lot about in terms of algorithmic decision making, and I'd love to hear your thoughts on it, is one question is, how does any decision maker, so it could be the person who's deciding whether to follow the Amazon recommendation, it could be a judge who's deciding on whether to release a particular arrestee pre-trial, how can this decision maker know whether reliance on the algorithm's recommendation is justified in that particular case? And it seems to me that overall statistics on accuracy, no matter which way we look at them, fairness, false positives, false negatives, might be only part of the answer if we want to know whether the recommendation is justified in a particular case. So, for example, some things we might want to know that those things don't get. Well, we'd want to know about bias, but other than that, we might also want to know things like how sensitive is my outcome in this particular case, or the outcome relating to the defendant in front of me, to specifics about how the model was created. So, I might be someone who is like right within the pack of people, like I am, for example. I read mystery novels, that's basically what I read. So I'm like way over there in the pack. If you recommend mystery novels to me, you're doing the right thing. But maybe there are people who, you're recommending a mystery novel, but actually if you had used a slightly different algorithm, slightly different model, you might have ended up recommending a different book. I might want to know where I stand there. And what are the metrics for doing that, and how important I think is sensitivity testing? And my guess would be probably more important than we seem to be thinking it is now. A similar question is, once I get this recommendation, how do I know, and this maybe is related to explanation in some sense, how do I know how to incorporate any other information that I know that's not reflected in the features that were available to the model? So I know things about my own preferences for books that might not be reflected in the model. Perhaps a judge has access to information in a particular case that's not reflected in the model. How do I know how to put those things together? That I think is a pretty hard question. So those are sort of my comments and questions about from Kartik's presentation. So now let me tell you a few things about Kevin's presentation. I am so lucky that like 2 weeks ago we had this great presentation at the Privacy Research Group about the blockchain. Whew, man, I'm really glad I had that. So I really love Kevin's presentation, and also he has some writing on this, which I looked at before. And mostly I just agree with a lot of the stuff that he's saying. I want to abstract even a little bit more from this question about governance, and I'm very interested in governance questions in general. But I want to abstract a little bit more from this question about governance to just question the idea or ask how we should really think about what kind of governance is going on in a particular system. So you can look at the blockchain as being basically distributed governance, democratic, shared governance, all those lovely things. But you could also look at it from a very different perspective as basically authoritarian. So the programmer, whoever programs the code, sets what happens. So we have kind of a programmer king model of governance, perhaps. Or maybe because we have lots of different programs made by lots of different programmers, it's not so much a programmer king as like a programmer mini kings, but if those mini kings tend to have particular shared features that affect the way that they approach their programming, then maybe we have something more like an oligarchy, expert rule, something like that. Or another possibility, because of the way in which, as Kevin pointed out, your influence depends on things like, how many servers you're running on the blockchain. Maybe we shouldn't be thinking about this as at all like democratic governance and much more like corporate governance, or shareholders. And maybe that is a kind of analogy that we should be thinking about. And certainly there is a lot known in the legal community about problems that can arise there, how to try to handle them, and so forth. And so that leads me to a comment on the governance by design proposal. First of all, I have to say that I'm a little worried about this just because of the experience with privacy by design, which I think has not been a huge success. And the reason it hasn't been a huge success is the same reason that there could be problems with governance by design, which is that part of the problem with privacy by design is that who is doing the designers? We still have an issue, and I know you recognize this too, of who are the decision makers. So the basic problems are about legitimacy and power. Who's making the decisions about governance? And these are really sort of, to me, in my mind, seem like very classic administrative law problems about how do we deal with the relationship between democracy and expertise. We need expertise in a lot of contexts. How do we combine that with democracy? And there are no simple slam dunk responses to that, but it is an issue that's been discussed a lot. And also, I think a comparison with open source is quite interesting too, because in studying commons governance, which is something that I've been doing for a while with Brett and Mike, who I think are both here, one thing you can see is that commons governance can be great, but it's not necessarily great. It depends on, again, who is governing it. In open source, in fact, governance structures are often extremely centralized. When you talk about actual power to, say, commit things to a new version and so on like that. So the role of that wide, huge group of people contributing is still, first of all, mostly only programmers, and even then, mostly what they're doing is saying, hey, I found this problem. So even commons governance isn't magic and usually requires governance structure. So this actually leads me to my final thing I wanted to say, which is really kind of, in a way, repeating Helen's question from yesterday, kind of the plaintive, why don't they listen to us? Law has been dealing with these same issues forever, right? It's the rules versus standards problem. It's the question about when should intent matter, when should it not. It's limitations on when we require specific performance of contracts. It's the idea of efficient breach, so on and so on and so forth. So why have we done such a bad job of sort of communicating the fact that we've been thinking about this stuff and sort of what we have learned over all these years to the people in the technology community? And I think we could easily say it's all their fault. They're a bunch of arrogant techno-libertarians. And shouldn't they know that software always has bugs and stuff like that? But I also think it's worth thinking about us, like what could we be doing better to reach across these boundaries and not come in with an arrogant way ourselves and say, like, well, we know how to do this, but just to simply say, look, these are problems that are not new. There's a lot of work in thinking about what's done with what to do about them. Maybe we should try to learn from each other on that. So those are my comments. And at this point, I don't know if you guys want to respond at all, or we'll just open it up.
Yeah, want to get some.
Let's open it
I don't
up.
know where the microphones are. Let's see in the back. So yeah. Let's see if you want to pick. Yeah.
So let me launch by saying I'm sort of a trade association standards person in some of my career. So I would like to ask, is there any effort to think about these at a meta-organizational level, that is an association of blockchain providers, standards that they might adhere to?
So yes, certainly in the enterprise world. So for example, there's something called the Enterprise Ethereum Alliance. There are consortia. There's one called Hyperledger that's under the Linux Foundation that's standardizing these things. In the sort of public blockchain world, there are trade association type vehicles. There's one thing called the Center for Digital Commerce, but they're not technical standardization bodies so much. So there are, and right now really it's the platforms themselves are trying to work it out. There's people building interoperability layers, but not thinking about it in that standard sense. So I agree with you. I think that would be a fruitful direction.
Oh, meanwhile, there's someone with a mic over there.
Okay,
Yes.
good, all right.
Okay, so I couldn't help but think that here we are in Philadelphia, 230 years to this year from a constitutional convention where we had actually addressed many of these same questions concerning override the rules, permanent rule change, organizational governance of the network. Like all of these questions are very similar. So I ask, where are the institutions in supporting an infrastructure that actually serves the interests of the people who use it? It seems to me that Foucault had referred to escaping the gaze as something that people want to do when they have an interest in interacting in the world in a private way. And it seems that privacy is a major motivating factor for people using these cryptocurrency and distributed transaction networks. So my question is, why do we not see institutions express an interest in promoting a privacy-enhancing infrastructure that may or may not use distributed ledgers, but is something that people can actually use for the reasons that they use cryptocurrency networks and DLTs that promote privacy today?
It's a good question. We do. It's very preliminary. And part of it is, again, this culture that says this is a lot of people who don't want to be part of any club that would have them as a member. There's a sort of, but we're seeing, for example, the Bitcoin community having these sort of terrible debates about. There are some efforts to say, well, gee, the IETF, for all its warts, did a lot of these kinds of things pretty well. Let's at least look at what they do and figure out what parts of their process make sense. So there's some efforts. There's efforts to create what's called self-sovereign identity. Because one key layer of this is to have some identity construct that is decentralized and empowering of the individual. And so there's efforts to build, there's something called Project Indy, which is part of Hyperledger, that's trying to do that in a sort of serious, thoughtful, institutional creating way. But right now we're still at this point where like the developers are on about the third or fourth floor of the house, and you're talking about building the foundation. And their view is, well, we'll get to there when we get to the roof. But yeah, it's really needed.
So I have two questions for Kartik. So one is that it's related to the polarized and the non-polarized group in comparison with CF and then the stochastic CF. So I was just wondering if you have tried the complete random recommendation. So basically, if you have 4 items, just 25% probability to each item. I mean, in principle, if your hypothesis is true, you have to see more polarization in the polarized group, right? So I was just wondering if you have tried that. And then the other question is, I was just wondering if the discrepancy between your study and then the 2014 science paper that you introduced, can be accounted by a little bit like a cold start in your problem. So in music, you probably don't have a cold start problem much, but in the Facebook, political stance, type of things, the cold start might play a role, in terms of polarization. So I was just wondering, between the two, yeah.
Sure. So your first comment question was, did we consider other recommender design, in particular random recommendations? So we haven't done that, meaning tested with random recommendations, but we are indeed thinking about, looking at a wide class of recommendation algorithms beyond the classic one and one minor variation of the classic. So you even have, the recommendation algorithms that Amazon uses today, for example, have changed a lot. There's a lot of machine learning in there, so it's not as programmed in a sense. And so we are planning to do some of that. I think random is an interesting idea which we could put in. And that I think also relates to a comment that you made earlier, which is that it's the exogeneity of preferences. And I think what we ultimately did was we varied the data and the algorithm. You could also talk about varying people's preferences, because ultimately the data are coming from people's preferences, and we proxied for that by varying the data. But instead we could say, well, here's a world where people have these kinds of preferences, and here's another world where they have these other preferences. And so that's another direction we could have gone. And your second question was about cold start. For those who are not familiar with it, it's the idea that, when you start these systems, initially there's no data. So where is that data coming from? A new item comes in or a new user comes in, you'd have no information about the user or the item to be able to make recommendations. And so how does that come in? I think it ties in nicely to our point that initially the algorithm uses data, and the question is, what's the structure of the data? And if you have a cold start issue, what are the assumptions that the algorithm makes to address that? And ultimately, these are all the design questions within the algorithm, which clearly have an impact. And we were mainly focused on trying to demonstrate through a simple example that ultimately that algorithm and the data, they can interact in very counterintuitive ways.
So for Kevin, I've got a question. There are public blockchains like Ethereum and Bitcoin. There are private blockchains like Fabric. By the way, thank you for the indie shout out because I work on it. But there are private blockchains like Fabric and Sawtooth, and now you have emerging public permission blockchains. I'm a owner of Bitcoin, but I'm not a miner, which means I don't have a say in the network. Can you talk a little bit about trust frameworks and what they do for the user, as well as the overall governance of the network is super important, but also there needs to be some sort of how is the user impacted by trust frameworks and in this idea of governance?
So no, it's a very good question. And most of these trust frameworks don't really conceptualize any role for the user, except to the extent they think of the user as a holder of coins, and that basically gives you voting tokens and power in the network. So you're right. There is, again, if we want to go back and draw these analogies, I mean, there's nothing like an electronic frontier foundation or something that thinks about itself as protecting the interest of users of these networks. Part of it is, again, right now it's so early and so messy that the question of it's really there's different groups of users. Are users people who want to buy Bitcoin as an investment? Are users people who want to transact? Are users and these a lot of these private networks, these permission networks have no native currency. So they're different kinds of users. So it's I guess I would say it's a good question. I think it's too early for us to really say anything robust about who the users are to figure out their interest, as opposed to by proxy the sort of development community taking the interest of the network into account as a whole.
So we're running low on time. So what do you think? 2 more questions? One more question?
Yeah, let's take 2 more
Take
quick
2 more
questions and then we'll answer
Right,
them. So,
take
yeah.
them without response.
I wanted to volunteer an answer to your final question, Catherine, around what can we do or what have we done wrong, and a really impractical, and I don't know how we'd implement it. So we have to improve education of history and philosophy, which has sort of fallen out of the canon. And what was really striking me, all 3 presentations, including Michael, the theme that came out to me is that the really hard problems here, they're all ultimately philosophical, and they're not technological. I mean, those are interesting, but those are sort of solvable. And if you look at whether it's dealing with biases and separating correlation from causation, ultimately that's philosophical. Filter bubbles have always existed. Now they're just more obvious. I mean, the U.S. lived in a giant national filter bubble for many years. Now people are upset because it's no longer the nation state that defines it. And that goes into blockchain. One of the interesting things in blockchain governance is the first potentially, because it's tiny, but I agree with your big potential. It's a technology that is antithetical to the nation state in terms of governance, and deliberately so in terms of many of its founders. So in that context, how do we how do we get out of this techno bubble in terms of technology can solve all our problems and get back to, the sort of, as you say, this has existed forever since humans became sentient.
And
So
one
I'll-
more question and then response.
So I'll
please,
essentially just follow up and
where are you?
and
Oh, there you are.
ask.
Hi, you're hi.
I have one, yeah. Really, in some sense, to ask both of you to answer Kathy's thoughtful questions, in the sense that one question Catherine asked was, what's the mechanism for this unusual result you have about polarized becoming more polarized under stochastic as opposed to feedback? Our data, which replicated the Bakshi, Messing, Adamich paper in using Twitter, actually saw highly asymmetric polarization, suggesting that there are two populations, that the right looks more like your polarized group, and everybody from the center right to the left looks more like your mixed group, with a normal distribution of attention on the mainstream. So if you can think about what the mechanism is that causes this polarization, I think it would map very well onto the data we saw in the 2016 election, in fact, in terms of patterns. And just really to follow up on this, to think that blockchain is like the internet early on is to assume a certain problem. What's the problem that it's solving for? And following up on what Chandra says, it strikes me that the problem it's for is the state, right? It's non-fiat money from the start on Bitcoin, and it's solving the problem of the state. So is there really something for which we need trustless trust? Are the rules, standards questioned? The way we solve them is always by creating authority and then dealing with the problem of legitimacy. And so the question becomes, is it even right to think? Right? We know from Joe Freeman, from Tyranny of Structurelessness, Iron Law of Oligarchy, it's all going to come back. That's why we create structures of legitimacy. So the question is it even right to think of it as at the level of the internet? Or should we be thinking of it at the end of the day that idea is more on the model of cyberspace in John Perry Barlow's mind? It's just wrong in terms of what it did. And is it instead just a good auditing and accounting system that will be built onto other systems? Should we just stop believing this story that it's as foundational technology as the net?
Who wants to go first? So very quickly, I think that first story that it's solving for the problem of the state is wrong. But I don't think that leads to, therefore, it is not of the same class of foundational technology to the internet. No, I completely agree with you. That is the misnomer, and it's the same misnomer that the cyber libertarian visionaries had 20 years ago, where they thought that this is the purpose of the internet, and if the internet does not overcome the state, then it's a failure. And I think that's the same false analogy being done here. It is not of the same. It is not the same, but a change in record keeping is not a small thing. I mean, if you ask Max Weber, double entry bookkeeping is the foundation of all of modern capitalism. So I would put it more, and of course then has all kinds of, if we're talking about Weber, all kinds of political and bureaucratic and other kinds of implications. So I see it in that light, that it is like the internet in terms of having this deep potential to reorder society in good and bad ways, but also like the internet in that it is incorrectly thought of as being a solution to the problem of the state when it just, of course, it's going to recapitulate it.
Last comments?
So on the question about the mechanism, which was a great question, by the way, I'll offer a potential mechanism, but I'll qualify it by saying that we aren't yet there in terms of fully nailing it and figuring out what are all the relevant interactions. Because as I mentioned, these are, it's not a first order effect. This is an interaction that we're trying to understand. But the mechanism that I'll offer is that, essentially, first let me recap the result. What we found was that in a world that's already polarized, the stochastic recommender that's actually saying, I won't take the article that is most popular among your friends, and just recommend that, but I'll probabilistically recommend everything they're consuming. It's making the world even more polarized. Now, one way this happens is that when we are essentially saying that what we can recommend comes from people like you, so we're already kind of asking what are people like you consuming, and then we're asking what we recommend. Now, within that, if we recommend the most popular item, we're looking for something that among people like you, there's enough consensus that this is something that we care about, that this is something that we like. So it's a more central news article or a viewpoint within people like you. But when we say that we'll find people like you and we'll recommend any of the things that they've consumed probabilistically, it makes it more likely that a story that's more fringe among people like you now gets more visibility. And so now you start to see more of the fringe viewpoints among people like you, and so you might also become more fringe, more extreme. But on the other hand, if the initial world you're in is in a global village kind of world, people like you, it's a global village. Everyone's consuming a lot of cross-cutting content already. And so you ask what else are they seeing, not just the most popular item, but also what else are they seeing. It's not these things at the extremes, but it's something else that's also a new viewpoint, but perhaps not the central viewpoint. So I think that's my explanation for now. But we're really in early days in terms of first figuring out the mechanism in that particular case, but also in evaluating other algorithms, other data sets, and so on.
Thank you all. Okay. We'll take about a 15-minute break. Again, there's some food in the other room across the way, and then we'll come back. We'll push lunch back a little bit so we can get back on schedule.
So can you measure that? Oops.
Yeah, those are really good questions, by the way, from both of us.